beginning of my talk. My water's already gone. There we go. Okay, before I get too deep into the slides, I mean, I do have some slides that I want to talk through, but really, I want to get into some code, and so I want to make sure that we spend time looking at some code in Visual Studio, and I've just created a little front end with Angular to call the RESTful services that are in there, and they're really pretty small. So let me just maybe take a look briefly at the application that we're just going to take a look at here. So it's a little budget app. As with most developing projects, I was thinking I was going to make it a lot more robust than it is, but time was against me. And then the reality is I don't really want to focus on the front end. I mean, contrary to what this screen shows, I do actually care about user interface. This is not exactly pretty, but in any case, I just have three basic tables that I'm working against: users table, categories, and then of course the budget or expenses. This is something that I've kind of toyed around with a little bit, just since I travel a lot. I kind of need to keep track of my expenses, and so in the past I've just created a little database to store some of that. And this is a really kind of trimmed down version of how that might look, just to track that. And I'm not looking at income. This is really strictly just expenses. So it could go a lot deeper than this. In any case, so with the categories, we could add a category if we wanted to. Let's just look at what the categories are: food, housing, transportation, miscellaneous. Got to have a slush fund for whatever I want, right? And I'll add that to my category. And then, of course, I've got users. None of those are me. And then in my home screen, that's just expenses. And we'll take a look at some of the things that we're going to talk about. And is how do we deal with things like paging and so on. That doesn't seem like, when you first think about REST, that should be a big concern in things, but it's something you actually have to think about as you look at RESTful services, and we'll talk about some of those things. And let's just get back to this. Okay, so all of the code that we're going to have here, I've uploaded to GitHub. So if you want, this will be available, I guess through the NDC website as well. And of course, you can see the link there. But you can download the slides as well as all the source code with this as well. It just uses a SQL Server database in the back end. For those that just got out of Cosmos, I'm sorry, it's not a Json style database, but that's all right. Okay, so what are we going to cover? Well, we're going to talk about REST. What is REST? So just so we have a basic understanding. I think we need to set kind of a groundwork, because really the building of the RESTful service, once you understand it, it's really quite easy in Web API. So we'll cover what is REST. We'll take a look at ASP.NET Core Web API. We'll talk about some of the things you need to set up just to configure it. Again, it's gotten really easy, so it's not that hard to configure it, but we'll take a look at that. And then we'll take a look at Swagger. What is the role of Swagger when we're dealing with RESTful services, and why might we use it? REST and the idea of REST is not new. I mean, this whole idea of communicating distributed processing, even before SOAP and ASMX web services, it's been around much longer than that. We had DCOM before that. I remember building websites in classic ASP where we communicated with UPS through XML with GET and POST methods only. So it's not that this idea of communicating with a server with a distributed and business to business, or not so much business to consumer. It's been around for a long time. We had .NET remoting that came out with .NET, of course, as well. So we had either ASMX web services or .NET remoting if we wanted to do things internally. And then the limitations of SOAP or the ASMX web services kind of gave way to WCF then, which really is, I guess, it's a combination of ASMX and .NET remoting, because you could really choose to do both of those within WCF. In fact, REST has been around for a long time. So why did I list it as one of these last things? Because REST was actually available before WCF, but it kind of became popular, a lot more popular around that same time. And the first RESTful services that we could build in .NET were in WCF. So that was, if you really wanted to truly take advantage of all the RESTful verbs and actions, we had to do that in WCF, like the ASP.NET web forms and ASMX didn't allow for that. We only had get and post methods at that point. And of course now there's GraphQL, and there's going to be a talk on GraphQL right in this room, right after me, which that's a pretty exciting new opportunity of things that are to come, and a way to program your distributed applications. So all of those are still available. Well, WCF really is, like I said, from WCF, REST, and GraphQL, all those are really available to you. So how do we choose between those? Let's just compare those just real briefly. Obviously, we're going to focus on REST in this session, but I do want to take a look at this. So WCF, or SOAP, ASMX Web Services, really their primary, the primary thought there was we want to distribute our business logic. We want to move it somewhere else. And so as you look at old SOAP SOAP services or WCF services, that's really how they're architected. The idea is we're moving business logic over to a different layer. So we make these, we call these endpoints with web methods. We'll take a look at some of the ideas. Because it was so flexible and we're moving the business logic, in order to really make best use of these type of services, we had to have heavy documentation. You had to really understand what are the services, what are they trying to do. So it's a very tightly coupled type of scenario. Even though we're distributing our processing, the front end or our client was pretty tightly coupled to our back end. In fact, if you're still using WCF services, you can have basically connected services, well, similar to oh, my mind just went blank. WebSockets, there we go. We have open communications and things, and you leave a session open on the server, and you're communicating back and forth. So you have to, it's very tightly coupled. You really have to understand what's going on the server. Very good for full stack developers, where you really have to understand the entire process front to back. The endpoints, as I mentioned, have many methods inside of them. For example, because there's so much business logic there, you might return different structures. The way your data looks when it comes back, or what goes in, can vary very drastically from one call to the next. And so really, as I mentioned, this is, as we want to take a look at, that's really, we consider that kind of our business layer. What about REST? REST is really a lot more resource-driven, and we'll take a look at why in just a moment. But it's really based on the resources that are there. There's really, if you understand REST, there's not a whole lot of documentation that's required, because you understand the structure, you understand how REST works. So the documentation goes down quite a bit. Each endpoint is very well defined as well, so it has few actions. In fact, the actions that it does have are pretty well defined as well. And really, we can probably look at that as much more of a repository layer than a business layer. We don't do a lot of business logic on the REST endpoints. What about GraphQL? That came about, and does GraphQL really mean the death of REST? So GraphQL, similar to REST, is really focused on resources. Not only the resources, but one of the limitations of REST is a resource within REST doesn't really know much about its resources. So we'll see is you have to make a lot of calls to get all the data that you want on a specific client. Whereas with GraphQL, the idea is you're not just focused on the resource, but its relationships. And as the name implies, it's a querying language. You can actually define what data you want. Just like in a SQL database, when I do a query, I can join multiple tables. I can specify individual columns that I want. So with GraphQL, you can actually define within your query what your data structure should look like when it comes back. So there's some pretty strong benefits there as well. It's much more of a semantic model. If you've ever done any kind of business intelligence or built kind of a back-end data model, like a semantic model that analysts need to use, the concept is very much the same. You have to build the structure on the back end and really have a well-defined model that can be easily queried on the front end. So there's some heavy lifting on the back end to make that happen. And similar to REST, again, it has a few actions. And also, think about it more of a repository layer. It just responds to what we do. It stores the data, knows how to get the data, and we can update, insert the data, and so on. The business logic doesn't reside there. The business logic communicates with it and then determines how to go there. So a couple other things. Server-side versus client-side development. So I just wanted to, as I was preparing for this, I kind of thought, well, what makes these three different? The server in WCF is very flexible. You have your business logic. You can make it do whatever you want. And therefore, it requires all that documentation because the clients have to really understand how to use that. So the client, therefore, is rigid. For a client, for a web developer or a mobile, Android, iOS developer, to be able to get any changes, they have to come to the API team or the server developer and request changes, and so it's very rigid, and there's the bottleneck there. With REST, the server is quite rigid. It's well-defined, as we talked about, as far as how the RESTful service should work. And the client is actually also quite rigid, which if you haven't experienced that, we'll take a look at that as well. It's, because this RESTful architecture really defines what the server can and can't do. That means the client has to adhere to those same type of principles. GraphQL, in GraphQL, the server, again, is quite rigid. There's some heavy lifting. Rigid is maybe the wrong term there, but there's some heavy lifting just to build the model that I was talking about and making sure that's available, and really all the work is done there. And that is because we want the client to be extremely flexible. So the client can say, hey, this is the data that I want, and then they can do with the data whatever they want, and then send the data back. And the server developers have to determine how am I going to deal with that data, and how am I going to process that and make sure that we still have data integrity at the end of the day as well. So there's trade-offs between all of them. So the question then again, which do I choose? Well, it depends. There's not one that's the right answer. Really, they all have their place and where your development goes. So let's just take a look at some of the ideas in this simple application that I was talking about. With WCF, if I wanted to go with this data, if I want to get, for example, like a summary of data on one of my pages, I would come in and I could get the budget item, I could get a username, and pair it up with all the expenses that user has incurred, and maybe summarize the expenses for each category for that user, and I can return it all in one time. So because of that, because of the flexible nature of WCF, I can have one endpoint and one method that would do that. So usually it would probably be called something like get users and budget by category or something like that. So the more you start developing this, and as you can see, this is just 3 tables. So as you start developing this, the endpoint names or the method names start to look more like paragraphs than they do like a quick action. With REST, on the other hand, we're really focused on the resource and not the relationships. So with the relationships, the trade-off there is I can just have a verb. I can just say, get me all the users. But then for each of the users, I then have to go, I have to make another call to say, get me all the expenses. And then I have to get all the categories as well. And then the client can determine how to deal with that. Now, of course, we can filter it so we don't have to get all the users in the database and deal with millions of expense records just so I can display 10 records on my screen. In GraphQL, once again, there it's related. It's an object relationship, and we can define, okay, I want the users, and I only want their first name and last name, and I want to see, so I can build a report, so I can say, I can specify which fields I want. Just first name, last name. I just want the category name, or I guess if we're going to go all the way through the relationship, I want the amount of the budgeted items and the category name. I'd still have to do some aggregation on my side potentially, but in any case, it gives me some more capability of determining what data I want and not getting too much data back. So what does REST actually solve? Well, as I mentioned, it's a well-defined architectural standard. The idea is we're separating the business domain or the business logic from the server-side resources. We have a very well-defined set of verbs and actions, limited set. And it focuses on the resource, not the business logic or the relationships. So let's take a look at some of these, what some of these WCF or SOAP methods might look like. I already mentioned some. Get all users. I might have one service that has this get user by ID. Get user and budget by user ID. Get user and budget, oh, typo. Get user and budget by category ID. Insert user, update user, delete user, so on and so on. This is by no means, I'm sure you've all seen like APIs that just have dozens or maybe even hundreds of methods that just get so convoluted and you need a dictionary just to know what's going on, what each of these methods are doing. Conversely, REST has just a set of verbs. So we have get and get. That's not an accident. Because get, usually what you'll see, if you haven't seen it already, we have at least usually two get methods. One to get a list of all methods, one that gets an individual item. We have post. This is post and put. This is one, I don't know why, but people seem to have there's some confusion around which one is an insert and which one is an update. Post is the insert, and put is the update. The idea here is that a post, obviously you're inserting a record, and with put, we're replacing the entire record. So if we're going to stick strictly to what RESTful services say, I'm looking the resource up by ID, and whatever I have, I'm just going to replace it. So it's not really focusing on I'm replacing individual items or individual portions of it. I'm updating the entire record. Because that was so common, and some of these objects are rather large, we need to have an idea of being able to replace or update just a portion of it, and that's where patch comes in. Patch is probably not that often used, but and it was added later to the REST documentations. But patch is like put, except for it does give you the ability to just send just a portion of the resource and specify what you want to update. Delete, of course, allows us to delete a resource, and then we have some others options that allows us to basically query an endpoint and just say, well, what methods are available? Get, post, put, delete, and so on. It'll return that information. Head is really just kind of a ping, and then trace. Trace is another one that's very rarely used. That just can be used for debugging, but it also opens up some vulnerabilities, so it's actually not really recommended to use that. What about idempotence? What's idempotence, and why is it important in REST? Idempotence, you can execute an action as many times as you want, and it'll have the same effect on the resource. So, as many times as I do an update, if I execute the same update statement, it will always result in the same result. So, because of that, RESTful services just define what actions are idempotent and which ones aren't. So get, of course, get is idempotent because we're not. The result might be different if somebody deleted it, but the fact that I'm doing a get, I shouldn't be affecting any server-side resources, so that is idempotent. Post is not idempotent because if I do an insert multiple times, I'm adding a new record. I'm creating a new resource over and over, so it's not idempotent. Put, it is. It's an update. Delete is idempotent because once I've deleted, if I go to delete it again, it's not going to delete another record. It'll just not find the record and not delete it. And patch, like put, is also idempotent. ASP.NET Core Web API. If you build a Web API with ASP.NET Core, that does not mean it's a RESTful service. It's just a framework, and it supports REST. It supports all the verbs. And as I mentioned, I would say many, and probably most, for sure most web services that I've seen are not RESTful. And that's largely because we treat them like they're WCF services. We treat them more like a business layer than we do as a data layer or repository. REST is really, besides being an architectural standard, and there's some things in place, it's really a mindset, and we have to change the way that we think about dealing with our resources. And it does require adoption or buy-in by both client and server-side teams in order to make that happen. Now, obviously, if the server-side team controls the RESTful service, the client has to buy into it. But in any case, I also want to say that REST is not the answer to all of your problems. There are definitely some challenges to be solved, and that's why there's still WCF services and why there's GraphQL that came about. What about Swagger? Well, Swagger just is a tool. Really, it's a documentation tool, very similar. If you ever built SOAP services or WCF services, you're probably familiar with the client generator or WSDLs. So the XML documentation for the service, and then you could go and generate a client, actually a wrapper for your XML web service or for your WCF service. Swagger gives us some of those same capabilities. In some ways, it's actually cooler because with Swagger, we can go in and we can actually test the services right there. I know we could do that with SOAP as well, but it seems like this is a little bit more flexible. We'll take a look at that in just a moment. Okay. Let's take a look at Swagger real quick. With Swagger, with the resources that we've mentioned there, we've got, excuse me, with categories, I've got get, and you can see with this get, with Swagger, I can open that up, and there's a try it out button, and with execute, of course, it allows us to then execute our command, and we can see, so we can test our service right here. We can test the individual endpoints. In addition to that, notice that it shows, and it's color-coded. That's a bonus, I guess. So you can specify which endpoint or which verb it is that we're testing. Get post. Here I have. We'll get into why I have 3 different gets underneath expenses in just a moment. But let's take a look at building our service. And we'll get into looking at Postman as well. I am in the wrong ID. Okay. Normally, I would definitely not do this project in a single project. I'd have at least 3 projects that have data transfer objects or DTO library that has my data objects and interfaces. I'd have a data repository, but for the sake of simplicity, I have my models and my data layer right in here. I am using Entity Framework Core for this. So if we just look at the DTOs briefly, then we can build from around there. So my user class, just like the database table, has user ID, first name and last name, category, expenses, let's start there. I changed my mind as I was developing this. The database table's budget item, and I had budget item ID here. I wanted to call it expenses, so we have all the same properties of their expense ID, user ID, date time, and so on. And then category, they're very simple POCO objects, right? For my entity framework, we simply created a database context. And really, if you're not familiar with entity framework, I don't want to get caught up in entity framework. Really, I want to get to the meat, which is just talking about dealing with the resources in a RESTful way. So, but here with entity framework, this allows me to manage the objects. So I've got a database set or DB set of users. They're basically just my rows, my users, expenses, and categories rows that we can work with. So there are a few. First of all, if I were to add a new project from in Visual Studio, it will run as Microsoft always does. They'll give you a demo controller that allows you to, has the RESTful endpoints values with some strings, but it'll run automatically. It doesn't have Swagger installed, really there's no need to have Swagger. If you understand the service, if you understand the endpoints, then you don't have to have Swagger. Swagger is really just the documentation. But to get things going, since I do want to have Swagger, there's a couple of things that we need to do to set up our project, and that is in our service API. There's a startup.cs, and in our startup, we have this configuration. So that's where the application is going to start. I need to set up configuration services. By default, the services.add.mvc is going to be set up for you already. API versioning, that was not set up. Sorry, that's one that we had to add in there. So if you want to enable versioning of your RESTful services, then we need to actually add that in as well. That's a change in .NET Core 2.2. It used to be added right into the core framework, but now you need to add a NuGet package for that and add the reference in here. Excuse me, for Swagger configuration, one of the configurations we had here is, so I added just a cookie policy, so checking for cookies, just that they're coming from the same site. I added a configuration option. Actually, I don't need this anymore because I changed the way that I was doing that I was handling this inside of here. So I don't need the configuration here. That was because I was going to read the connection string from a configuration file. Cores, cross-site scripting will be important. Now that's mainly if we're going to be using our service, if we want to expose it to an Angular or React client or Vue.js client or something like that. So you need to have your core. You need to add cores, and in addition to that, you'll see that in adding cores, let me come down 1 second. There's configure services, and there's another section that is just the configure section, where with our cores options. So after we've added cores, with use cores, we need to specify where we're going to allow that. Here I've just opened it up so we could allow requests from any client, from any origin and any method. You could really limit that to, at this point, that you're only going to allow get, post, put, just which items you want, and which origin or what URL, basically, what clients you want to allow that for. So in talking about security, obviously, those are some things that you want to consider and make sure that you only allow requests from the right place. But there's more than that, obviously. Excuse me. The other thing that Swagger requires is we need to, when we say app.useSwagger, and then we need to specify where our Swagger definition is going to come from. So Let me run this one more time and just show you what we're getting from our Swagger definition. And really, what is Swagger? So here we can see a Swagger, a screen that helps us kind of test that, but there's a link right here that's Swagger v1 swagger.json. So if I look at that, that was defined right here in my Swagger UI, where I'm going to pull that information from. So I have a name of the Swagger client, and then also where the JSON or the definition is created. Really, Swagger, if we're using Swagger, it's just a definition document. It can be done in YAML or JSON, and then we could distribute that very much like we distributed WSDL documents, and then clients could be generated from that. Excuse me. So if I look at this swagger.json, you can see that it really is just a JSON file. I'm not going to go through and describe what all this does for us. Just know that it describes what methods are available, what data types are in there. And from that, this UI is actually, this test UI is actually developed as well. So we can see that there are 3 endpoints that were created: the categories endpoint, the expenses endpoint, and the users endpoint. Additionally, it'll also show you what models are available. And if we're strict to adhering to what REST does, the models should closely resemble how many endpoints we have that we're working with, because we don't want multiple different models working within a single endpoint. So our category model just defines it. This looks like our tables and our DTOs that we looked at earlier. Okay. Let's look at building the controllers. Once we've built our models, we can build our controller. And as you've probably experienced as well, if I go to my controllers and I choose add controller, because I'm using Entity Framework, I can choose to create a controller with actions using Entity Framework right from here. If my Entity Framework is outside of this, if I really have a separate repository layer where I'm going to manage that connection, I wouldn't do this. I'd manage these directly. But for the sake of demonstration, we can definitely see what we can do with that. And so I'm going to choose add. I'll just go with a simple model right here. From within my model, I'll just go with a user. Actually, user and category about the same, and I'm just using my budget context. Because I already have a users, this is just going to create users one controller. We'll go ahead and hit add. And it only creates the 4 methods or the 4 HTTP verbs that I talked about earlier. It doesn't even create a patch for us. So we can see that it creates, just because I'm using Entity Framework, it creates a budget context, so my database context inside of here, and it will actually build all of my logic for me. Woohoo! I generally like to have a little bit more control over that, but with our RESTful services, we have HTTP GET, and then we also see based on our URL, we can also see with the path that we can see we have an HTTP GET with the ID, and so in this case, the example is that the ID would also be would be part of the URL, so not in a query string. So those are 2 types of query strings that we can control, and there's going to be some reasons why we want to limit them in different ways. We may have a path parameter, or we may have query string parameters. So we'll look at that just momentarily. The get, both the get, notice this is a list or an IEnumerable of users, and the get by ID returns just a single user. And that's why I said we usually will have 2 gets. Most of the time, you're probably going to have more than that. If you want to allow the users to control, to filter a little bit more, you'll definitely have more gets than that. But what you don't want to do is you don't want to get out of control and start having them not, well, I guess passing in multiple query parameters is fine, but you don't want to change what it is that you're returning with each of the different types of gets. Our put, notice that with put, and post. Actually, with a post, all we have is we're inserting a new user, so the only thing is we're passing in the user. With a put, this was something that was kind of new to me when I first started coming into RESTful services, is I'm passing in both the object that I'm updating as well as the ID of the object, so the primary key. This concept, I mean, really in the development that I'd done before that was kind of foreign, because the user already has that ID. I'm updating user. I should already know what the ID is inside of there. But that's a standard, or that's kind of a standard practice, as to pass in the ID for whatever reason, just to guarantee this is the ID that we have in here. Notice that with the logic that Microsoft puts in, they actually check to see if the ID that we passed in matches the user ID, and if it doesn't, they'll return a bad request. And this is just a kind of demo logic that these web services put in for us, that the scaffolding put in for us. And then post, like I said, just as an insert. If we look at the logic, it does the insert and then returns a created at action. So it actually will return where it came from, so we can recall that action if we want, which is a get user. So in other words, we can pass in the get user with the ID, so we can return the actual object that was inserted, so we can get the new ID from there as well. Same thing with delete user. We don't need to pass in anything but the ID. We're just deleting an object, so why pass in more data than we need to? And just to help our method inside of there. The other thing that we want to look at, that we want to consider as we go through, as we build our services here, I had several thoughts that went through my mind, and I forgot the one that I started. It'll come back to me. So, but really, one of the things that we definitely want to consider is how are we going to use the data, obviously, and how many records are we dealing with. Now, for a very simple application, this may be all we need, but as our application grows, we may have millions of records that we're working with, and returning all millions of our records just doesn't make a lot of sense. So let's look at let's dig into the front-end application and see how we're using that. Actually, I did want to look at Postman first. I know that if we look at Postman right here, I don't know if have any of you guys, I recently found this Insomnia. I don't know if any of you guys have seen that before. It's basically like Postman, but I actually like it better. It just seems like it's a little bit easier to use. It does the same things for us, where I can go in with Insomnia, I can pass in the URL of the object that I want to get, and I can specify if I want to do a get, post, put, patch, delete, or any of the verbs that we talked about. So I can test each of these manually from here. So if I'm testing my users, let's just go with that for right now. I can't test it unless it's running. I'm going to come back to and delete that second controller that I just added. No, it didn't. I had that in there before, yeah. So, in fact, even without Swagger, I would be able to use Insomnia or Postman directly from there. And like I said, Swagger is really more of it's kind of a documentation tool. It allows us to have some manual testing, but it also allows the clients then to know what the contracts are. And so we're building contracts around that. And that's where versioning comes into play as well. This isn't what necessarily what I had in mind before, but one of the thoughts that I had was with versioning, you also want to be careful how you version your endpoints and your APIs. One of the places that I worked where we had really more of a WCF style web API, we called them RESTful services. They were anything but RESTful services. They did exactly all the things that I just mentioned are in there. So we had one method that was called get customer, and we returned a customer object in a certain way. It had all the data about the customer, and there was all kinds of data within there. And then one of the our Android team, I think it was, they said, well, we want to have a get customer, but we only want this data. And so the client was dictating what the API team was supposed to be returning. And so what we ended up doing was we created another get, in fact, another get customer, but we called it version 2, and it took a different input and it returned a structure that was completely different from the previous one. So we had version 1 for iOS and version 2 for Android, and then they were talking about creating a third version because they were wanting to move away from that. That goes against the whole concept of why we're even moving to this RESTful services. The idea is that we define what our resource looks like, and then we have this repository. It controls how we gain access to that, and the client manages what it does with that data. So, excuse me. Okay, so it's running now. If I've got Insomnia running here, I just have my localhost users. If I hit send, it will return my list of users. Because of the users, the way that it's set up, if I pass in a parameter of user ID 2, when I hit send, it should only return that one user. I'm going to go ahead and, in my Swagger service, one of the nice things here too is if I'm going to go to users, if I do a post, notice here's an example. So it has the JSON for me on what the example should look like. Let me come into this users, and I'm going to add a post inside of here. With a post, I don't want to put a 2 because that would fail because it wouldn't find that resource. That doesn't exist. But here I can now, where's the, come on. Body type, oh, there we go, JSON. So user ID, since I'm passing in user ID, posting that in, I'm not going to pass that in. That'll be created for me automatically. We'll just go with Gregor. And sorry, I can't zoom in here. In Postman or in Insomnia. Otherwise, I would have used Postman there for that. So, but since I've chosen a post, I need to pass in the body of the text. In this case, all I need is the first name and the last name. We'll hit send, and it returns that object for me. And notice that is because when I hit post, where's my user? With the post method, what do I have here? Oh, that's put, sorry. I can't read. Because of this create action method. At the end, it returns an action result user, so it'll actually go and reuse that get user method and return that created at action for me and return the user object. I can verify that user actually exists now by going back to get, and I'll choose send, and we'll see 6 users, and I'm there at the bottom as well. What about, we'll go with expenses. And I know it's capitalized inside of there just because that's how my controller is, but it doesn't need to be capitalized. With my expenses, I've got several expenses, not a whole lot of expenses, but you can imagine as this app gets used, there'll be hundreds or thousands of line items inside of here. So we want to be able to, with our expenses, I want to be able to dictate how I'm going to pass that. So with my expenses, this is one of the places where I might have more than one get inside of there. What I want to manage, let's open up the expenses controller. I have a HTTP get, and there's an HTTP get by ID. I actually inserted this in the wrong place. Let me stop this real quick, and I'll show you what happens with Swagger when I try to create this in a certain way. So Okay, by default, I have my get, I have the get all, and it's just going to return all expenses. If I want to return individual one, I pass in the ID, and because I've passed this, oh, I guess that's one thing I want to mention. The route is an important part of these web APIs. With ASP.NET MVC and Web API pre.NET Core, we could control the routes. We still can, but a common way to control them was that we had in our startup, we called a route config file, and we could have multiple different types of configurations. They were all in one central place. As Microsoft has gone through and as developers have kind of have worked with this, they realize, it's much better to control which route I'm listening to right at the controller. I'd rather be able to dictate that for this method right here, that I want to specify what path I want to listen for, what route I'm actually listening for. So for the class, by default, you'll see up at the top, for web APIs, it'll put API and then in square brackets controller. So it just defaults to whatever the controller name is. You could specify the controller here to hard code that, but by having it in square brackets, it dynamically determines it is based on the controller name here, expenses in this case. And that's why the web API or Swagger use the capital E for expenses. If I want to change that, I can just change it to lowercase expenses right here. And that means that every method within this controller will have that as the base route that it's listening to. So the only thing that I need to define in here is anything that deviates from that. For example, HTTP GET, I'm not passing in any parameters, so I don't need to specify anything with that, and it will know to come here. With this get by ID, this will be appended, the ID in curly braces will be appended at the end of the expenses route using the get verb. And then comes the question, what if I want to add my own query string parameters? I want to be able to pass in, I want to get expenses by page, so I want to have a logic. I want to say, okay, I want page number 5, and here's the size of page that I want. So I can add logic to be able to deal with that paging. If I try to remove that page from there, this now becomes ambiguous. Swagger or the routing engine, it won't really know how to deal with the configuration here. So let me run this. And you'll see that Swagger is not happy. This is something that can be really frustrating at times when you come through this as you're building things. You know you've built it right. Then you come and you open up Swagger and it's not happy. What I found usually when I do this is I'll go and I'll comment out all the methods and one by one re-add them back in and see which one caused the problem. And that's because I need to specify a route that is a little bit more unique. Now I could have called this get expenses by page like it says here, and we could definitely have that up there, so it can be another endpoint. I prefer to just, I already know that I'm working with expenses, and I prefer just to give it an endpoint or a URL name called page in this case. And whatever I pass in a query string, ASP.NET MVC will, and that's with MVC engine, that's been around for a while, it'll actually map those items to us. So as long as the query parameter is page, they're named page and size, it will map those to those parameters. Now I've made them integers. If they're not integers, that's gonna fail on me here. But it does that mapping for us. I hate saying it this way, but it's fast and it's true. It's MVC magic happens, right? It's not magic. It's just mapped. So, but we've got the magic that's in there that maps that to there, and then I can pull that out. Excuse me. Let's look at real briefly on the client. I don't want to get deep into Angular at all, but what I do want to show you is just the 3 services that I'm actually using that call the API. So I've built in the expenses, there's an expense service. I didn't flesh all of them out. I can't zoom in here either. Is that, well, with the expense service, you know what? I will just take this, put it in. Okay. So inside the service, basically, I just create a variable expense URL, which is my base URL for expenses. The HTTP client for Angular happens to be just, all I have to say is return http.get. I'm specifying the return type, so I've just got a generic there, and I need to pass in my URL. Unless I want to pass some additional information within the header, there's nothing else that I need to do inside of there. So React, I guess if you use Axios or Vue, whatever you're using there, they've all got wrappers around this that make this very simple to be able to do that. As long as you have your URL and you know what the data type is that needs to go in, you can pass that in. For the, if I want to get, so this is all expenses, where I just get expenses, this expenses URL. For this top one, I've just added in the page ID and the size. And then I've only done an add expense inside of here, so I didn't deal with the update or anything. But notice that this is a post. So for the post, I just determined I didn't need to worry about the data, so I just called it as a void, so I'm not waiting for any data that's back. I passed in the expense URL. And then my object, this is just a JSON object that the web API will pick up on the other end and insert. We've got just a minute. There's one other thought that I wanted to look at here, and that is I wanted to compare one of the issues that, one of the downsides of using REST, actually, and that is in the expense component. In the expense component, when I want to display my expenses here, I want to display the username, the category, and the amount. So the user's information is not part of the expense. All I have inside of there is user ID, their category ID, and so on. That means I need to go into the database. I need to go and make a call, or at least 3 different calls. One to get all the budget items, one to get the users, and one to get the categories. There's a couple of ways of dealing with this. I just want to show you some of the potential issues that you might run into by dealing with this. So one option is I could call get expenses, and then as I go through my get expenses, what I do is first I go and get all the expenses, and then when I get them back, I can do a for each loop through every expense and call the get user and get category service for that individual user. Let me call get expenses here. Let me save that, and you're going to notice a huge difference immediately. Maybe one that shows that it doesn't even work. Response error. Well, let me just describe it since we're out of time. What's happening is for all the users, and I've even trimmed it down to where I only have 5 expenses on a page. I make a call, in that scenario, I'm making a call to 2 calls for each row, each expense. So one to get the 5 expenses plus 10 more to my web API just to get the users. A way to get around that, obviously we could deal with, you could add some caching on the client side to be able to avoid that round trip. The way that I got around it here is I first called and made sure that I loaded just a collection of users and a collection of categories first. So I called get users, and when I got the users, I then called get categories, and then once I called get categories, then I called get expenses. and then instead of looping through and calling my web API for each user, I just went and did a find against that. And even there, that may not be the best option. Something that we did fairly quick inside of here. But those are some of the things that you want to be concerned with when you're building RESTful services. If you're going to build the RESTful services the way they're intended, each endpoint should focus on one structure, and that on one resource only, and not the relationships to other resources. But the real world is you're not going to build a page that only accesses data from that one resource. You need to get access to the related data. So the client, it really puts the burden on the client to determine how am I going to get that other data. And if I have an object that just has users, first name and last name, but then I go to expenses, and it might have, in the database, it might have 50 columns or however many columns, and I only need 2 of them. When I make the call to the get expenses records, I may be loading a lot more data than I need. So those are decisions that really all those things are decisions that go into using RESTful services. And how do I mitigate that? What kind of caching am I going to put in place? Not just on the server side, but even on the client side. So I guess in the end, with REST, if we go that direction with REST, it's well defined, and it makes it very easy to build the server side. It makes it easy to separate the client from the server, and you can really expose your service to many more clients and have a standard for everybody to follow. But again, there's some other considerations to deal with, and I would go ahead and say that REST isn't the answer for all, isn't the solution for all problems. Thank you. I should end on a positive note. It is the solution for many problems.